The application of analytical techniques for the study of ancient pottery since the 1960s has demonstrated the potential of the analysis of clay raw materials and tempering agents directly related to the manufacture of the pottery and the natural properties of the final product. In the Aegean and the Eastern Mediterranean, there are two main types of clay sediments used for pottery manufacture. One is the iron-rich terra rossa sediment of Quaternary age and usually of alluvial origin, and second, the calcium-rich marly sediment of Neogene age. The application of archaeometric techniques for the study of ancient pottery and raw materials for over 50 years now has demonstrated also the complexity of the approach. A pot is not a rock, and direct comparison between pots and raw materials is inconclusive and pointless. As ethnographic research has shown, the human agent is of major significance, with potters manipulating heavily their raw materials through sieving, tempering, and mixing. Hence, what we analyze is not the geological source, but rather the human agent and the potter's choices behind pottery manufacture. The application of petrographic analysis in both archaeological ceramics and raw materials allows a better understanding of pottery recipes. Through analysis, we take a step before consumption, which is usually the case in pottery studies, and we try to decipher pottery production. In this endeavor, we have to tackle the obstacle of the stable geological background versus the ever-changing geomorphology of an area. The aim of our hunt for clay materials is not and should not be to locate ancient clay sources. This is impossible because first, clay outcrops are in most cases shallow and can be exhausted within the lifespan of a potter. And second, the geomorphology of the area has most definitely changed many times since prehistory due to natural and human-induced processes. Therefore, what we're looking for is to examine mineralogical and petrological characteristics of the geological background of an area against those seen in the pottery recipes that we consider broadly local. And what is local? In an area like Crete, it is difficult to define local. The geology of the island is complex and repetitive, and the same geological series are encountered across the island due to the fault system. For this reason, we need a very solid corpus of ancient pottery samples from various sites covering a range of dates, shapes, and wares in order to define the local component of each assemblage. Having said that, what we present today is the complete opposite. It is one of the very few cases with a fabric of rather clear origin, representing a very specific geology that is not common in Crete and reflecting a very specific area. It is the case of the granitic dioritic fabrics. These fabrics are easily identified macroscopically thanks to the presence of acidous igneous rocks, granite and diorite, which give the fabric a characteristic salt and pepper appearance with mixed black and white grains that you see clearly here in the section. This fabric is very common across East Crete from the final Neolithic to the late Bronze Age and in historical times. Furthermore, it has also been found in Knossos and other sites in central Crete, suggesting that this pottery was traveling across the island using networks of trade and exchange throughout Cretan prehistory. There are two main recipes that have been described macroscopically and petrographically, one with more leucocratic minerals, the white bits, which is the granite, used mainly for cooking wares, and one with more melanocratic, like black minerals, which is the diorite, and characteristic pellets used for transport and storage vessels. The granitic dioritic pottery is traditionally regarded as originating from the northern end of the Ierapetra Isthmus, from the broader area of the Mirabello Bay. This association with the Mirabello is based on two arguments. The first is the geology of the central and western part of the Mirabello, which consists of Cretaceous limestones of the Tripolitsa zone intruded by a dioritic to granodioritic rocks from which the main tempering agent derives. The second is that this area has two major Minoan centers, Gournia and Priniatikos Pyrgos, and both have provided evidence for pottery production, with kilns and granitic dioritic fabrics being the predominant component. For this reason, this particular fabric is often called Mirabello fabric in the bibliography. Now let's move to the southern part of the Ierapetra Isthmus, where the situation seems more complex. For decades, Myrtos Fournou Koriffi and Myrtos Pyrgos were the only excavated settlements in the area. The detailed study and petrographic analysis of the material from Fournou Koriffi showed that a large component of the assemblage belongs to granodioritic fabrics, which according to the prevailing belief are regarded as imports from the Mirabello area. However, new evidence from the plain of Ierapetra allows us to reconsider the association of the granitic dioritic pottery with the Mirabello and offer alternative interpretations. Over the last 10 years, there has been an impressive increase in excavations, surveys, and geoarchaeological projects, changing drastically our view for the area. Several archaeological projects were carried out by the Ephorate of Antiquities of Lasithi, the National and Capodistrian University of Athens, and the Institute of Aegean Prehistory, including the excavation of sites of almost all Minoan periods. An early prepalatial settlement at Aphrodite's Kefali, a late prepalatial cemetery at Schinokápsala, a protopalatial peak sanctuary at Pandotinou Koriffi, a large neopalatial mansion on the mountain site of Gaidourofas, a neopalatial peak sanctuary at Stavromenos, rich neopalatial pottery deposits at Bramniana, and a neopalatial settlement on the island of Chrysi. Additionally, intensive surface survey carried out over the last 3 years by the aforementioned institutions provided rich evidence for human occupation in the area during Minoan times. All these projects are rather recent, and with the exception of Aphrodite's Kefali and Bramniana, the publications are still in preparation. However, the study and analysis of the ceramic material is quite advanced and has shown that diachronically, the pottery of all sites along the Ierapetra coast is characterized by two main fabrics. The first is connected to the ophiolite series and the fleece melange outcropping in the broader area of Myrtos and westwards, and is considered broadly local. The other fabric is granitic dioritic, which, as already mentioned, is traditionally considered an import from the north coast and the broad area of Gournia Kalochorio and Priniatikos Pyrgos. However, the attribution of the granitic dioritic pottery from sites of the Ierapetra area to the production centers of the Mirabello should not be taken for granted for two reasons. The first is that granitic dioritic fabrics constitute a large part of the ceramic assemblage in all the new excavated sites, sometimes reaching even 40% of the total. This suggests that it would be difficult to regard all this pottery imported from the Mirabello. The second reason is that outcrops of granite and diorite do not exist only in the Mirabello, but also in the north slopes of the Ierapetra plain around the area of Kapistri. To the above, one more factor should also be taken into consideration. The area of Kendri, in the middle of the Ierapetra plain, was a major potting center in the 19th and most of the 20th century, suggesting that local clay sources suitable for pottery manufacture existed in the area. With the above in mind, our research, our research project combined clay prospection and geological sampling with petrographic analysis of raw materials, Minoan and modern pottery, in order to explore alternative sources of granitic dioritic materials and investigate the origin of granitic dioritic pottery found in the southern part of the Ierapetra Isthmus. Now this part, the southern part of the Isthmus, is characterized mainly by neogene formations with marls, sandstones, and limestones, everything in orange and yellow in the map. Whereas alongside the isthmus, there is a quaternary alluvium formed with materials transferred and deposited by streams and rivers, which is the central gray part on the map. In the central part of the isthmus, near Kapistri, here, there are Cretaceous limestones intruded by eroded acid igneous rocks, mainly granite and granodiorite. Different clay deposits were sampled, whereas sands and gravels were collected to be used as tempering agents. All samples were naturally levigated in water and turned into briquettes. In some cases, the clays were mixed with each other and or tempered with non-plastic materials. The briquettes were fired at 900 degrees and thin sectioned. The comparative material used comprises Minoan pottery from the data bank of the East Study Center, as well as modern pottery sherds from the traditional potting village of Kendri. The modern pottery samples were collected from several old workshops, the ruins of which are still visible in the countryside around Kendri. Now let's have a look at the results of the analysis. First, we start with the geological samples. The petrographic analysis of the geological samples showed that granite and granodiorite appears along both rivers of Ierapetra, Kendrianos and Kapistrianos, mainly along the latter, Kapistrianos, which springs from the mountains where the granodiorite outcrops lie and runs into the coastal plain towards Ierapetra. All samples collected from neogene marls are calcareous, with a considerable amount of micrite and frequently shells. Red earths have also a calcareous component as expected, since the neogene marls constitute the geological background of the area. Granite and granodiorite is apparent mainly in the samples collected near the outcrops, where it appears in well-formed subangular grains. It consists of quartz, feldspar, biotite, and amphibole. Further south, along the rivers and in the plain, there are mainly fragmented parts of granite and less diorite. This is also to be expected due to the erosion of the rocks and also because granite seems to be more abundant than diorite in the source of Kapistri. At the estuary of the rivers, granite inclusions are more eroded with cracks on their surface. It seems therefore that the granite and the granodiorite inclusions differ in appearance depending on the sampling point. Other inclusions comprise quartz, some metamorphic rocks, sandstones, and chert. The petrographic analysis also showed the presence of inclusions connected with the ophiolite series, such as basalts, dorites, pyroxenes, and epidote. Such inclusions are apparent mainly in some samples from Episkopi, along Kapistrianos, and rarely along Kendrianos and the plain. Finally, in a few samples, there is phyllite deriving from the phyllite quartzite series of the northeast of the isthmus. Now let's have a look at the modern pottery from Kendri. The analysis showed the existence of 3 fabric groups. The majority of the samples belong to fabric group 1. Dominant inclusions are granite, granodiorite, and micritic limestone. Frequent are sedimentary rocks like sandstones and chert, while volcanic rocks appear very rarely. In fabric group 2, the predominant inclusions are granite and granodiorite and some phyllite. Micrite is common, while sedimentary rocks are few. Shells, epidote, and pyroxene are very few. Fabric group 3 contains mainly granite and sedimentary rocks, while there are few volcanic and very few metamorphic rocks and fossils. Fabric group 1 presents similar mineralogical composition as soil samples collected from the plain of Ierapetra. It is therefore clear that the geological samples represent locally available raw materials. Fabric groups 2 and 3 are not incompatible with the geology of the area, but our analysis failed to identify geological samples that match these fabrics. In any case, the presence of phyllite, macrofossils, and shells indicates that groups 2 and 3 represent a different clay source than fabric group 1. And if we put all this comparatively, the raw materials collected from the Ierapetra plain and fabrics of the modern pottery samples from Kendri were compared to Minoan granitic dioritic pottery from 3 sites in the wider area, namely Schinokápsala, Brammiana, and Stavromenos. Excuse me. The comparative petrographic study shows that the red non-tempered Minoan recipe, which is represented here by the Brammiana cooking pot, and it's the one containing mainly granite and used for cooking wares, is very similar to the raw materials collected in the plain and fairly close to fabric group 1 from Kendri, although most Minoan pottery samples are less calcareous. I hope you see the similarity of the Ierapetra raw materials with Brammiana cooking pot and less to the Kendri modern pottery. Regarding the Minoan jar fabric, which is the Brammiana transport jar down here, its matrix is almost always very fine, possibly refined through sieving or levigation, and the non-plastic inclusions were added as temper. This is a very specific recipe and is rather different from Ierapetra's raw material, as it is much richer in diorite. Going back to our initial statement that a pot is not a rock, there cannot be direct comparison between raw materials and a rather standardized ancient recipe involving strong manipulation, such as levigation and tempering by the potter. However, the difference between the raw materials and the Minoan fabrics regarding the frequency of diorite may indicate not simply a different technology of manufacture, but possibly a different source of raw material for the production of Minoan jars. On this basis, it is considered possible that some of the Minoan pottery, at least the red non-calcareous cooking wares, originate from the plain of Ierapetra. To sum up, this study focused on the relationship between the clay sediments and tempering materials collected from the wider Ierapetra area and the granitic dioritic Minoan fabrics, which constitute a major component of ceramic assemblages in sites around the Ierapetra plain. The presence of granite and diorite in a large number of geological samples and traditional pottery from Kendri clearly suggests that some of the granitic dioritic pottery found in Minoan sites of Ierapetra could have been produced locally. This seems to be the case, at least for the red non-calcareous cooking wares, while for the finer calcareous jar fabric, the evidence is less conclusive. In any case, our study showed that the association of Minoan granitic dioritic pottery with the Mirabello region should not be taken for granted, and that the presence of center for the production of this pottery in the plain of Ierapetra should not be excluded. On the contrary, it is possible for one more reason. The Mirabello area is traditionally considered as the only possible source of granitic dioritic pottery because the Ierapetra Capistri outcrops were not connected to any known habitation center. Recent excavations in the periphery of the Ierapetra plain and the ongoing survey of the plain itself have produced ample evidence for a rather dynamic and complex pattern of habitation in the area. We need to analyze more assemblages in order to confirm this suggestion, but this initial geoarchaeological study showed that the combined analysis of geological samples, ancient and modern pottery, may challenge long-lasting ideas and provide new evidence in order to tackle old problems. Thank you very much for your attention.